Okay. For today, um, I wanted to finish up lecture question 4.3. I finished up everything for 4.3. I didn't give you guys time to work on them. Then I want to move on to 4.4 and 4.5. 4.4 really is sort of like the same stuff that we were doing for chapter 1 and 2 and 3 and 4, where basically certain things on the equation for a function do prescribed things to its graph. So you guys know what those things are already. We're just going to add one more function. There's specific properties for logarithms that we'll pick up in 4.5. And finally, for 4.6, you guys will start messing with the equations for them. So if we have a logarithm equal to something, how do you solve that? And same thing for an exponential. If you have something with an exponent in it, how do you solve for variable in the exponent? So for now, 4.3. I'm gonna give you guys 10 minutes with it. I think some of you guys finished this already, didn't you? I'm actually gonna turn off the camera so I don't slow down the video. Let me here. How, where, what, and why? Are people doing all right with stuff?
And
Julio, could you do the first example for writing equations in logarithmic form? I just want to make sure I'm doing it right.
Yeah. Just trying to do something. So, okay, so for that first one, our handy dandy thing is this thing. So the set of questions that you guys have, the very first ones at least, right? I believe you have the exponent and you have to change it to the log. And then the second set goes the other way around. I give you a logarithm, you have to change it to the exponent. So, it's basically great. It's this to that power has to be equal to that. So 16 to the x is equal to y. That's simple.
That's it?
Yep.
Okay.
So I give you the logarithm form for it, right? And I just want you to convert it back into the exponential.
Okay.
And then same thing for this one. Let me actually highlight it. I'll do the first one here. So this one would be log base n of 103 is 4. So notice the same idea here. This to that power is equal to that.
Oh, okay. So would we put log in the first ones, or just put? Oh, never mind. Never mind.
Okay. Have any of you guys have to make a have any of you guys had to make a supply run yet?
Not yet, but I feel like soon. We're
yes.
gonna need toilet. Where do we get toilet paper? There's no like. I don't think there's even anything right now.
I mean,
I went to Safeway and I told them that my mom said that they're restocking in 15 minutes. And she said she didn't have any, but she would, to give her my phone number, she'd hide some in the back and to pick it up and text her the next day. And that's what I did.
go. I heard a lot of shops or stores now are rationing off things like that. So you can't go and take like 8 pallets of toilet paper home.
Oh yeah.
Oh yeah. So one, they're rationing it off, and two, you can no longer return it. So if you bought 8 pallets worth of So if you bought 8 pallets worth of toilet paper, you can't return any of it. And that stuff is expensive.
Because people are overbuying.
Yeah.
And then they're not going to use all of it. And they're like, oh, I want to return it. Like, what?
Yep. Exactly.
Could you do 30?
And I do 30. Yep.
It would be 2 to the x equals 6, right? No?
Check your conversion.
Would it be x to this x squared?
So remember the conversion, I'm going to write it down here. So So a to the b is equal to c. You can convert that to log base a of c is equal to b. So that to that power is equal to c.
Oh, so it'd be log to the base 2, and then the c would be the 6.
The c would not be the 6. The c would be the x in this case.
Wait, what? Oh, okay, it makes sense.
You get this side, right? This is the side that we got.
Are the is the homework for chapters 4.1, 4.2, and 4.3 up yet?
The online stuff?
Yes.
Not yet, because I completely forgot to put it up.
No problem.
So I need to put them up. And like I said, I'm not going to worry about due dates. Just make sure you complete them.
All right, no problem.
Oh, it'd be 2 to the 6 equals x.
Exactly.
Okay. And then the other one would be 9 to the half.
Yep. So I need to now go make a supply run.
What's gonna go?
Huh? I'm thinking of going to Costco like around 2 o'clock.
Good luck.
Good luck.
Yeah, I know. Well, it's I mean, maybe the rules don't apply like this anymore, but I'm thinking hopefully it's 2 o'clock on a Monday. Hopefully nobody's going to be there.
They're going to be there.
Like, even with the coronavirus, everybody's just going to be at home.
Oh, I doubt that.
Yeah, that's what I'm thinking. Like, maybe the rules won't apply that way anymore.
There's more people out now than ever.
Huh?
There's more people out now than ever. Anytime I go anywhere, it's packed. Anywhere I go.
Really?
Yeah.
Wow. Well, I've got we've got latex gloves in the car. I have an old ski mask I can wear just in case. Hopefully nobody thinks I'm trying to steal. That's it. All right. Any more questions on this stuff? 4.2? No, 4.3.
Yeah, actually, for so if you go all the way to the right on the lecture questions, it's the
Yeah.
third one down on the right. For that one, would it be log E and then
This one, right?
yes. Wait, let me check it out actually. Where's my zoom? Yeah, the E, yeah, that one right there. Would it be log E and then H or parentheses H equals K?
Right.
Wait,
So the
wouldn't
only-
you also call it ln?
Right. So this is just nomenclature. What you did, Hunter, was right. That thing, we just call it LN.
All right, no problem.
That's it.
LN? Why would you call it LN?
So remember how so there's a log. Whoops. There's log base 10 and log base E. These two happen so often that they just get called log for the first one and ln for the second one. That's it.
So when there's an E or when there's any variable?
So these two, just these two, right?
Mm-hmm.
Automatically, you can call them these.
Okay.
All other ones, if there's any, if we need another thing down here, we will explicitly write it.
Okay.
Does that make sense? So if you see just these hanging around, just log and ln, you know that those are log base 10 and log base E. Anything
Okay.
else? So if I need to do log base, I'll have to write it in. I'll have to write in the two. Does that make sense?
Yeah.
Okay. All right, let's move on. I know you guys don't wanna.
This is as easy as hell.
Yeah, this last chapter was pretty easy. Okay. We got to do logarithmic functions, graphs of them. So like I said, this is all stuff that you guys have already seen before. We're actually going to add a couple things, but it doesn't really require you to learn anything newer. It's like I said, repetitions of stuff that we've done before. So we have two graphs here. And what I want you guys to notice is that's log, this is a 2 to the x. And this is log 2 of x. So turns out both of these functions, they're inverse of each other. So then this is actually g inverse of x, and this is actually f inverse of x. So if you have 2 to the x, you use logarithm 2 to undo it, and then same thing in reverse. If you have log base 2, you exponentiate it to get rid of it. Cool?
Cool.
Okay. So the domain for, how about this? What is the domain for log of x? So what does that domain look like? For that?
Probably
Infinity?
What is it?
0 to infinity?
Right. So notice it starts here and then it just keeps going that way. right? So a couple things about log base 2 or log in general. There will always be on a basic graph, vanilla logarithm, there is an asymptote right here at x equals 0. This happens whenever yeah. Ding.
Sorry, that was me.
That's cool. Okay, so this right here is one of the new things that we're going to add into our little rules. So what are the two things that we can't do in math?
Divide by 0 or have a negative inside of a square root.
Right. Does that make sense? So I'm going to write it over here. Math no-nos, the things that we can't do in math, right? Two. I think I might need to recalibrate my pen. Okay, so the first one, well, the first two is ones that we know and love, right? So the first one, divide by 0. We can't have 50 divided by 0, undefined. Cool? The second one is a negative inside an even root. So if you plug these into your calculator, you plug either one of these into your calculator, it's going to give you an error. So then now, the very last one is the one that we're going to pick up today. You can't have a negative inside a logarithm. So remember how back in the day, we used these two to find domains, right? We now get to add this one to find domains using logarithms. Got it? So real quick, domain in the vertical asymptote of log base 2 of x plus 3. So really quick graphically, what does that plus 3 do?
Does it move it to the left 3?
It moves it to the left 3. Why to the left?
Because it's positive.
Because it's positive. So you do it opposite the sign. So then this should tell you, so this right here should tell you, right? Move it to the left 3, right? Which means we are grabbing this thing, this function right here, and we are moving it this way, 3. Does that make sense?
Mm-hmm.
Okay. Where does that mean our asymptote is going to be? So instead of 0,
Would it be negative 3?
it'd be moved to negative 3.
Got it.
Okay, so we just did that graphically, just thinking it out, what that thing should do and what this thing's doing to our graph, right? The way that you would show that algebraically is using this rule right here. We need everything in the logarithm to be positive. So we need that x plus 3 to be greater than 0.
Wait, could you repeat that?
Yeah. Using this rule, right, we want everything in our logarithm to be positive, right? So the thing that's inside of our logarithm is this stuff right here. So that's the thing that we want positive. Hence the reason why we need to solve this equation right here. This automatically tells us, so we need to do minus 3, x is that thing, minus 3.
Oh, and that tells us.
So this right here gives us our domain.
Oh, that's the domain.
Right. So this is going to be from -3 to infinity, right? And our vertical axis will be x equal -3. And we are done. Well, I wanted to use green for answers. Got it? So same thing with the example 2. Oops. We need that to be greater than 0.
We subtract 5 from both sides.
Right, -5, minus 2x is that thing, -5. So
Did you
here,
divide -2 from here?
huh?
You divide both sides by -2 from here.
Right, divide by -2, divide by -2. So here's a thing that that is sort of like your algebra that you're going to have to pick up. See how we are dividing by a negative?
Yes.
Since we divide by a negative, that sign turns the other way. So now we have x -5 over -2. But since it's two negatives, they turn to positive.
So our domain would be 5/2 to positive infinity.
Not positive infinity.
Oh, negative infinity because it's less than.
Exactly. So then the domain, let me put it over here. Domain is -infinity to 5/2. And where should the asymptote be?
Would it be at 5/2?
Yep. So I'm going to rewrite this. Let me move my domain over here. So I'm going to rewrite this. Log of -2x plus 5. This negative right here, what does that do?
Wait, could you repeat that?
The purple negative that I just wrote in. Let me actually rewrite it really quick because I erased everything. -2. So this negative right here, what does that negative? What does that do to your graph? Sorry.
Doesn't it?
Doesn't it make it thinner?
Uh-uh.
Makes it positive?
Mm-mm.
It reflects it over the y-axis.
Right, it reflects over the y-axis. So instead of having this kind of graph, we have a graph now that goes this way, like this.
So if it were on the outside, it'd reflect over the x, right?
Exactly. If you had negative log, let me write it in a different color. If you had negative log of x, then you would have something that did this.
Okay.
So this negative right here flipped it along the y-axis, right? So then it should go from negative infinity up to a point instead of from a specific x value up to positive infinity. And that's exactly what's given in our domain. Notice that it goes from negative infinity up to a specific point, 5/2. Got it?
Got it.
Awesome. Okay. We've got some practice problems here for you guys. And I learned how to use breakout rooms. So what I want to do is, yeah, this is going to be group 1, 2, 3, and 4. I'm going to send you guys to your breakout rooms so you guys can try these out. All I want is the domain and the vertical asymptote. Cool?
Cool.
And I'll be popping into the rooms here and there. All right. And you're off.
Three.
So where is everybody?
I don't know. I was wondering why is the only one. I was like, oh, is anyone in here?
No, so let me see something. There it is. Okay, we have Mohammed in here. There's got to be somebody else in here. Who else is in this room? Oh, so I think it's just you and Mohammed. Libby can't get her mic to work.
Oh, that makes sense.
Yeah, so you might need to talk to her through, I think she
The
signed
chat.
out for a second. Yeah, I think she signed out for a second. And she's probably going to try she's going to probably try her mic again. And if that doesn't work, try to talk to her through a chat.
Okay.
Okay. Okay. So you guys got problem 1.
How I have a few questions. The first one,
Uh-huh.
how do you know if it's like a greater or a less than?
Well, for logarithm and for exponents, for logarithms and for the even root one, both of those have to be greater than 0.
So it would be greater than?
Right. So for
Okay.
both of those
That's
cases,
right.
you don't have to remember anything more than that. They just have to be greater than 0.
Oh, okay.
Got it?
And then, yeah, and then also, with the +1, would we do x minus 2 plus 1 is greater than 0, then do -1 to both sides and divide -2? They get 1 over -2. Is that correct?
Is the plus
is.
1 inside the logarithm?
No, it's outside.
Right. So do you care?
No, we only want what's inside.
Exactly.
Okay.
Got
That
it?
makes perfect sense.
Okay. All right. I'm going to go terrorize another group.
Okay.
Let's see. Who can I scare? Oh. Let's see. I'm going to put him in group 2. Okay. Let's see. Okay. Bye-bye.
Bye.
What up?
So,
Okay.
what you guys got?
So for the domain, we got 3/4 to infinity, and then the vertical asymptote was 3/4.
Let's see. Yep.
Yeah.
Yeah.
Cool.
Log 6 and the -5 doesn't do anything to the problem.
Yep.
Okay.
No.
Cool.
We got this.
Yeah.
Yeah, we got it.
Yay. Okay. I'm going to go terrorize another group. Let's see who else I can scare.
Okay.
Let's see.
Okay, well, that was easy, guys.
I know. I'm actually understanding this. It's crazy.
Yeah.
Yeah. All right. Cool. All right. So none of you want to talk, huh?
Already finished.
We already
I think we already
finished.
did it.
Whoa. Okay.
Or that quick.
I know. All right. What'd you guys get?
For the domain, we got -9/5 to infinity, and the vertical asymptote is x equals -9/5.
Right. Woo. You guys have
So
got
if if the greater than or less, so if it's less than, would that make it negative infinity to whatever the answer is?
Mm-hmm.
Okay, so it's just switched.
Yep.
All right, not too bad.
Boom. Okay. All right. I'm going to call you guys back in.
Okay.
Woo! That actually worked out pretty good. That actually worked out damn good. People are still in breakout rooms.
He had it in the first example.
Huh?
Oh no.
The vertical asymptote for the bottom left one would be 3/4.
Yep.
So confused with what was going on. I was like, wait, he's not in our group.
Yeah.
Oh, we joined back. Okay, I didn't know.
Yeah.
my bad.
Yeah. We joined back up.
These don't seem too hard.
Yeah.
I'm caught up finally. Let's go.
Cool. Okay. So let's start. Let me actually get rid of the numbers. Group 1, what'd you guys get?
Who's group 1?
I got the domain is negative infinity to 2, and then the vertical asymptote is 2.
Close.
Is it 2 to the positive infinity?
Right. So tell me the math that you needed to do.
X minus 2 equals 0.
Not equal.
Or is it greater than?
Right. So then plus 2. Whoops. Look at me go. X greater than 2. So now, domain.
2 to the positive infinity.
Right. And the vertical asymptote?
2.
Right.
Oh, I was close.
Yeah, I think what you probably did was when you added the +2, you magically flipped this thing around that way. And I think that's where you got the minus infinity of the 2. So
Yeah,
the
I did do
flipping,
that.
so let me go back up here. This flipping right here, only happens when you divide by a negative.
Okay.
Only when you divide by a negative. Everything else, you keep it the same direction.
Okay, that's easy to remember.
Yeah. And now my computer's going retardo. Okay, there we go. But it erased everything. Oh my good. My good Lord. Okay. Only when you divide by a negative. do you
Okay.
flip the sign. Okay,
I
group
need
2.
to write that down.
What'd you guys get for a domain and what'd you guys get for the vertical asymptote? Group 2.
For that one, I got the domain at -1 to positive infinity.
Right. Whoops.
And then the VA would be -1.
Right. So the math +1 has to be greater than 0. So then x has to be greater than -1. Okay, the next two. These are a little bit more difficult. Yep, not by much. What'd you guys
So
get?
what we did, we put 4x minus 3 is greater than 0.
Okay.
And then we subtract 3 from both sides.
You mean add?
Or add 3, yeah. And then divide both sides by 4. Which gives us x is greater than 3/4. And then the domain would be 3/4 to positive infinity. And then for the vertical asymptote, we got x equals 3/4.
We are done.
Nice.
Are we comfortable with these? I think we've killed these, huh?
Yeah, these aren't. I feel like do you even use it like the outside number? I feel like you should ignore it.
Right. For a domain, you only care what's on the inside of the logarithm, nothing else.
Are we gonna learn what to do with that outside number?
Yep.
All right, for this one, I don't know if I'm right or not, but I got -9/5 for, yeah, that to the positive infinity, and then your VA would be -9/5.
Right.
All right, yes.
Boom. Boom. See, these aren't that bad. Okay. So what I want to do now is I want to present to you guys formally what a logarithmic function would look like. Okay. There's a bunch of stuff, a bunch of properties that we know that well, a bunch of stuff that we've already covered that is satisfied by the logarithmic function. Okay. So first of all, is it 1-to-1?
Yes.
What's the test for it?
The lines, or I don't know, I forgot the test.
Is it the vertical?
Right, those are the vertical lines, the ones that go up and down. So notice every vertical line that you draw crosses it only once.
I thought 1-to-1 was the side lines. The ones to the
Right. Oh
side.
yes, you are correct. It's the side to side. The vertical one is for function. Haha.
Oh.
Yeah, see? Even I got confused with them.
It happens.
Yeah, it happens, right? It
So
happens.
it's okay. So 1-to-1. Vertical is for a function, and then side to side is 1-to-1.
Right.
Yes.
I need to remember that.
Let's write that down so we don't forget.
I think it was on the test, so that's why I made sure I knew it.
Yeah. Okay. Vertical asymptote, where's it at?
0.
Right. So the vertical asymptote for this is always at x equals 0. The domain for it.
1, 2, 3.
So where does my graph?
to infinity.
Right. My graph starts at 0, x equals 0, and goes off to infinity. What's my range?
Oh, okay.
Range.
Those are my y values. Where do my y values go? From where to where?
Negative infinity to positive infinity.
Right. So this line keeps going down that way.
Positive infinity.
I need to use my space pen. So these values keep going down that way, and they keep shooting up that way. So negative infinity to infinity. X-intercept, where's it at?
Guessing it's at 1.
Right, 1, 0. So it turns out that that point, for any logarithm function, right, at least a vanilla one, that one, will always cross there. Okay, I give you guys a couple of key points. I'm gonna put them in pink. It's all of those. So notice how these work out. So the power of b is b to the 1, it's 1. B squared is 2, b to the third is 3. So notice what it gives out, right? So if you give it a value to some kind of power, it'll just give you the power back. Got it?
There's B1, 1, B2, 2, B3, 3.
Right. So then down here, right, b to the 1/2 would be what?
1/2.
Right. The output would be 1/2. It's spitting out the exponent. Right? So b 1/3.
Is 1/3.
Right. And b to the 1/4.
Is 1/4.
1/4. So these are the crucial ones.
Would those? Oh, okay.
Does it have a y-intercept?
I don't know because it's never gonna cross.
Nope.
Right?
Right. This is an asymptote right here, right? So it'll head toward it but never cross it. So it's none. There it isn't one. And it's increasing from where to where?
From 0 to infinity.
Right. Got it?
Yep.
Okay. So the graph that I gave you guys just now, the one that you guys are currently seeing, that's a vanilla logarithm for some base b. So that's why I didn't label the points themselves. I didn't give a specific value for b because b can be whatever you want. So that is example 3. So automatically, where should it cross the x-axis?
Should cross 3? Negative 3?
Where's
0?
Where's the x-intercept?
The x-intercept is at, I have no idea.
Oh, it's right above it. Right, it's at 1. So automatically, we have that point.
Why is it at 1? Oh, because it starts at 1 up there. Does it always start at 1, like
Yep.
the positive one? Okay, so
Right.
it always starts.
If you have a vanilla logarithm like that one, you always have this point right here. So what's another point we got?
B to the 1 and 1.
Okay, so what is that?
I didn't quite get that.
Oh.
You can also try spelling it.
So what's another point?
B to the 2 and 2.
Well, what? So first of all, b to the 1, 1. Where is that for log base 3?
I have no idea.
3,
So what's
1.
b in this case?
You just go
so
up
3 is
1, right 1?
Mm-mm. So 1 point will be here. I think somebody said it.
So you're just gonna keep over moving over 3 and then up 1?
Well, it's not moving over 3 and up 1.
You're
It's
squaring the b. It's like b to the power of f of x is how I like to think of it. So if you're gonna go up 1 spot, so the next one would be 2. So that'd be b to the second power. That'd be 3 to the second power, which is 9. Then
Yep.
that's how you would get 9, 2 as your next point.
Oh, makes sense. Makes sense.
So that's why I gave it to you guys sort of without disclosing a value for b. Like I said,
So
b
now
could
the 3 is the new value for B.
the 3 is the new value for this case. So
Okay.
the next point here is 3
27.
squared, which is 9, comma 2.
So
then-
the next one then be 3 to the 3 cubed.
Which is?
That'd be 3. That'd be 81.
Went too far.
3. Oh, that's 27.
27.
My bad. I was doing
7.
9 times 9.
And then what's the y value for it?
Let's see here.
So you had to do 3 cubed, right?
Yes.
So the y would be that one right there. So then this would be 3 cubed, 27, comma 3. Next couple, I'm just going to go ahead and fill in. You have a point here, which is the square root of 3 is 1/2. Or sorry. Crap, did I mess those up? I completely messed those up.
Why?
The ones in pink.
I royally messed it up.
Oh.
Notice how on the y-axis they drop by 1, but then I called them 1/2, 1/3, 1/4.
Oh yeah.
Yeah, so that was my bad.
I didn't catch that.
Yeah, me either. So let me leave that up there for a second. Oh man, and this is gonna be on YouTube.
Yeah, happens.
It
At
happens,
least
yeah.
you're getting this fix in the YouTube.
Right, yeah.
Just edit it out.
Right.
I have a friend who's taking an algebra class,
Yeah.
and her instructor's taking or she's putting all the lessons on YouTube too, and she didn't really know how to like screen record and stuff, and she only uploaded the first 4 minutes of every lecture.
Oh my God! Really?
now-
That's it.
Like intentionally, my friend was like, okay, so I don't have to go to the like online Zoom meetings anymore, and she tried to catch up, and like nothing was on.
Nothing was on there. Oh, that's horrible.
Yeah.
That kind of sucks. Okay. So in the next couple, I'm actually going to do. So then, whoa. The next point, this is going to be 3 to the negative 1, which is 1/3, comma, negative 1. The next one after that. So notice what's happening, right? 3 to the negative 2, which is 1/9, negative 2. And then the one that follows after that, now I'm getting like really close to the y-axis because well, that's what's happening. 3 to the negative 3, 1/27. Now we have each one of the, 7 points from the very beginning. One there, one there, one there. Make this a little wider for people to see. You guys got it?
Yeah, now I think I'm ready to move on to the next one if everybody else is. I'm not sure if everybody else is, though.
Yeah. Let me just go ahead and connect the dots really quick.
So what chapter are we supposed to be on right now?
Like, are you asking?
Like where do the does a school like where like want you to be like right now technically? Like in chapter 5?
That's kind of hard to answer. The reason why that's hard to answer is because the rest of the department is doing a couple of different things in terms of how to teach pre-cal.
Yeah.
I think there's maybe 1, 2, out of everybody, and I think there's like 6 or 7 classes that are teaching there are 6 or 7 pre-calculus courses. I think there's maybe 4 that are doing the similar thing, and the other 3 are sort of a hodgepodge of other books and other material and other methods. What I had planned out, I think we were supposed to start chapter 5 today.
Yeah, well, are we doing 3.4, 3.5, 3.6, 3.7, 3.8, 3.9, 3.10 and on, or are we stopping at a certain section moving on to 5?
We're stopping at for chapter 5. I think I only have it up to section 5.
What about 4?
Up to 7, and that's it.
Okay, so we have about 3 more sections after this.
Yeah. All right, real quick. Domain, range, asymptote, and x-intercept. What do we got?
The domain would be
0 to infinity.
would it be 0 to positive infinity?
Yep. Notice that didn't change, right?
No.
What's the range?
Would it be 0 to positive infinity?
Negative infinity to positive infinity.
Right, the y's. We want the y's.
Okay, you're right.
Asymptote.
Would it be at 3?
X equals 0.
Right. And what's the last one? The x-intercept?
0 or 1 0.
Right. So notice these 4 things didn't change, even though I said that we were doing this log base 3. So that b can be whatever you want it to be. Okay. So this one, we're only going to use a couple of the points, but it's all still there. Now we're going to actually see how to sketch these around. We'll see how to sketch them. So I give you guys a graph, log base 3. So there's a reason why I made you guys do this one in particular, so you guys can use log base 3 for the example. There's a couple things here. The plus 5 and the minus 1. What's the plus 5 do?
Left 5.
Left 5. And then what's the minus 1 do?
Down 1.
Down 1. So our vanilla graph goes through here, goes through here, and goes through here. And then there's going to be a graph right here, or point here, here, here. Got it? So what's the plus 5 do?
Gonna move it to the left 5.
Move it to the left 5. So the easier ones to move are these. So it'll tell you what's going to happen, right? So actually, let's start with this. Where's my asymptote now?
It's at -5.
It's at -5. So then this point moves over here, here, here. So our new points are that one, and that one. And I'm just going to draw the other ones in for reference. And then
You're just basically just moving them over.
Yep. So then this point moved over that way, over that way, over that way, right? And then finally, what's the minus 1 do?
Oh, you gotta shift it down 1.
Right. This is the one where we shift down, right? So we have our new points. We're going to move those down. I think I need the red pen. Got it?
Yeah.
Okay. And then finally now, our final line. Back to
Do you need to label the points at all or no?
Huh?
Do you need to label the points at all or no?
No. I mean, if you can do this in your head really quick, that's fine. I mean, that's the point behind all this, right? Where you can look at a function and say, oh, that's what this does, and that's what that does, and I'm done.
Okay, perfect. And then that's also like the main version of what we'll be doing with this, right?
Right. So our red one would be the final answer. So, domain.
-5 to positive infinity.
Right. -5 to positive infinity. Range.
Would it be negative infinity to positive infinity?
Right. Asymptote.
Would it be 5? -5?
Right. And then our x-intercept.
X-intercept would be at -4. It's
0?
at -2.
Right.
Oh, wait.
You guys see it?
Yeah.
It's right there. It's this point right here. You guys see how, if you need
How-
to,
How did it get right there and not over 2 more?
because of the shifts, because of these.
Yeah, but wouldn't it be since it's at 1, it'd be at -4 instead of -2?
Uh-uh. So you're talking about this one.
Yeah.
Oh, wait, no. Oh, sorry. Yeah. It's fine. So the red one is our final answer. I think you're still concentrating on that green point above it.
Yeah.
So that was
Oh,
with,
it's because you moved down 1, huh?
right. The red one is the final move down one.
Okay, I see. I see now.
So you guys see how useful that stuff is from the very first week of class. Technically, you guys have learned nothing new. Okay.
Whew, another one.
Yeah. So again, we're playing around with log 3. So then we know that our points go, the vanilla one, right, go through here. Whoops, too high. Here. And squared 9 here. And then I think one right here. Right, so our vanilla graph without the sprinkles is here, right? I said this is a rough sketch. Okay. That negative.
Is that reflecting it across the x-axis?
Exactly. That's reflecting it across the x-axis. So we're doing this. We're doing that, right? So basically, everything is where it's supposed to be except on the other side. So this point now comes here. This point comes here, right? This one just so happens to stay where it's at, but everything else sort of flip-flops over the x-axis. So back to kindergarten. Oh, whoops. Look at me go. Like I said, rough sketch.
That was easy.
That was easy. Switch it.
Yep. Got it?
Yep.
Okay. This negative. If it's inside the x, what happens?
It reflects across the y.
The
Or the x.
x-axis.
Y.
Right. So in this case, we're doing this time. Right? So same thing happens, except we're flipping it the other way. So this point gets to go here. This point gets to go here. This point way over yonder flips all the way over here. Right? And then same thing for the other point. So that goes there, goes there, goes there. And then back to kindergarten. Who's taking up a hobby?
Not me. I haven't been honest. I've been pretty busy actually with work and stuff. So
Good.
Cleaning has become my new hobby.
yeah,
Huh?
that too. Cleaning's fun.
Become my new hobby.
Oh my God.
I've been deep cleaning my room like once a day.
Deep cleaning your room once a day?
Yes, I find something to clean every single day. I'm like, oh, these dressers can be wiped down.
Yeah.
The struggle. Instead of doing my homework, that's what
Finally,
I'm doing.
over this last weekend, I've been meaning to give my kitchen a deep clean.
Hmm.
So I finally gave it a deep clean.
We're all cleaning.
Yeah, we're all cleaning.
We're gonna be so clean after this quarantine's over.
Right, exactly. All right. I am Dunzos.
Ooh.
So how about we do the next 20 minutes lecture questions within there? Go take a break.
Perfect.
Like I said, I think you guys got this pretty down pat. So
It's pretty easy.
yeah. I'm gonna go make myself a peanut butter and jelly.
Ooh, that sounds hit.
Right? I guess this is one of the good things about doing all this stuff at home is like when you're in class, you can't just say like, I'm hungry and then go eat something.
Go eat something.
Yeah. Like now you can say, I'm hungry and then go straight to your kitchen.
Get some food.
I'm gonna go take a nice trip outside. It looks like it's gonna rain again.
Is it? Oh, I forgot you live like in Bay Point.
Concord.
Concord.
So it's nice and windy.
It's pretty sunny in Oakley.
I can tell you it's about to change. Ah. So people are saying that we might need to stay self-quarantined till May.
Yeah, I've been seeing that, and I don't want to do that. Does that mean like businesses are still gonna be closed till May?
I think so.
Yeah, at this point, I'm convinced we're finishing the semester online.
I think that might be the case.
I'm pretty convinced that that's gonna happen.
Yeah.
It's whatever at this point.
Yeah.
I'm not gonna be at
really
LMC
hope not.
till-
Huh?
Probably not gonna be at LMC till the fall then if that happens.
Yeah.
It's just crazy.
Yeah.
And it's
Maybe-
not like it'd be one thing if we had the time off and the class was like online. I was like, okay, cool, we can go places, but you can't go anywhere because nothing's open.
Right.
Right.
Because everything's open. Yeah.
Like I could have gone on vacation and still done my
Yeah.
stuff online.
Yeah.
But nope.
My flight to LA just got canceled. I was leaving the first week of spring break and it just got canceled.
Really?
Damn.
Yeah,
Are flights getting canceled?
mine did.
Damn.
Yep.
I mean, could you still drive down there though? Is that selfish to ask?
I think you can. So I haven't gotten any reports of any of the freeways toward LA being closed. So I don't think the 5 have been closed.
My
don't-
cousin's actually driving to LA right now.
Yeah.
Really?
See, yeah, you can still go down. You can still come up if you need to. They haven't locked down those things. They just want you to stay away from other people.
Basically.
You can cross states and everything like that, right?
I think so. Yeah. I mean, I don't think states have locked down their borders yet.
Thank
No.
God.
Just want you
Julio,
to
if we were graphing log 2 now, is that different from log 3?
right.
So
You
how
was,
do we know how to start it?
that's why I gave you this thing.
Log B. Oh, so I can use that for anything. So
Exactly.
the value would be 2 to the 1, 2 to the 2.
Right.
Okay. Makes sense. Makes sense.
So after this, I'm going to give you guys the toolkit functions
For logarithm.
for logarithms and for exponents.
So for the first one, how do we find the y-intercept?
For the first one.
Yeah, the first lecture question.
Oh, that says y-intercept. I meant to say x-intercept.
Oh no, why? I was wondering. I was like, is it just DNE?
Yeah. So it'd be x-intercept. So don't worry about the y one. That's a
Typo.
or righto. Whatever. Yeah. Daisy.
So Julio, would the x-intercept still be 1, 0 no matter what?
Double check your moving.
No, I'm saying like for any log, like for the very like first equation. I'm graphing out just log 2.
For log 2, yeah.
It'd still be 1 because I'm gonna graph log 2 and then after that I'm gonna graph the transformation.
Yes.
Okay.
So no matter what, 1, 0 is your very first point.
For any log.
Yep, for any log.
Okay.
March was such a horrible month to put off a haircut.
Right. I can't get a haircut until like April.
Well, May now.
May now. Oh my gosh. Damn.
We're all gonna come out looking like Ozzy Osbourne with long hair.
For real.
So what would for the I forgot what the LN thing is called. Would that be any different?
Yes and no. So the only difference between you're talking about when you have like ln.
Yeah.
When you have ln of x, right?
Mm-hmm.
Like I said, it's equivalent to log base e of x, right?
Mm-hmm.
So in this case, your b is going to be e. So then the graphing for it, right, works out the same as it did up here.
Okay.
The only sucky part is you're going to have to mess with e, which is a nasty decimal.
Ooh, gross. Okay.
Got it?
Yeah, but what about for the third one? Actually, no, let's do the fourth one. The fourth one's a little bit more harder.
Yeah. So, state domain and x-intercept.
Mm-hmm.
Right? So what's the domain?
Oh, I haven't started that one yet.
For G?
Yeah.
Well, that's okay. Let's go ahead and do it. So, for the domain of any logarithm function, what do you need? What can we not do?
You cannot divide by 0
You can't divide by 0. What else is there?
in no negative numbers.
No negative numbers inside where?
The root.
Right, and the even root, right? And what's the
Yeah.
the new one that we just did?
What is it? I'm like looking at my notes.
She doesn't start reading more on her own.
I don't know.
I just brought it up. It's this one.
Oh shit! Sorry, I was looking at my notes.
That's fine.
Oh, no negative inside a logarithm.
You can't have negatives inside a logarithm. So that automatically tells us what needs to happen with that one.
Let's see. Oh yeah, there is a negative inside the logarithm. Does that mean the negative inside the parentheses, or is that like the negative ln?
Right. So we need this stuff. That stuff in here can't be negative. So this is where we had this thing. The 3x plus 9 had to be greater than 0.
Okay.
You remember that?
Yeah.
Tell me what to do.
Subtract 9 to both sides.
3x is that thing, negative 9.
And then you divide by 3.
X is
negative 3.
Right. X has to be greater than negative 3. So, domain.
That'd be negative 3 to infinity.
Right. Negative 3 to infinity. And then there's an x-intercept.
Which is negative 3. Oh, wait. Is it positive 3 because the sign, you have to do the equal?
Actually, no, you can't find the x-intercept for this one. Oh, my God.
Oh.
I'm thinking. Why didn't I ask you? Oh, my God. Don't worry about the x-intercept.
So, on these first 4, are we just doing what we did in like the first example?
Right. So, that's me writing myself a note that's a horrible problem.
So if there's a negative inside the parentheses, does that make it D and E?
No.
Oh.
So for this one, you should be able to solve for that one. You should be able to solve for an x-intercept. And then for the other, well, it's just this one that I chose badly. That's it.
That one, so the bottom right one?
Yeah.
What's wrong with it?
The stuff inside the ln, the stuff inside the logarithm, is a bit too nasty to do it using these rules up here, the ones that you would use for these 3.
Oh.
Yeah. For the other 3, it's easy enough to figure out, but for this one in particular, that one's going to be really nasty.
So it's saying and the x and y, or just the x-intercepts. Aren't we finding that one with when? Oh yeah, x. Yeah, you're finding that one. Never mind.
Yeah.
We're good. We are good.
Okay. I said there's always a. This is the second time I've used this stuff, so every semester I teach a class, I try to change stuff here and there. This is probably one of the ones I didn't change. So that's my bad. Peanut butter and jelly.
Would the bottom left one, would the x be the x value be -3/1?
Yep.
All right, cool. And the range on all these are -infinity to +infinity, aren't they?
Yep.
We are chilling. All right, these are easy.
Yeah.
All right, now for the fun stuff.
Now for the fun stuff.
The graphs. And all the homework assignments for 4.1 through 4.4 will be out today, right?
Yep.
Perfect.
I just haven't transferred them over. That's it.
No problem at all. And 3.8 was optional, so you just do it if you want to. And will that be on the test or no?
No, I'm gonna take
Okay.
the test.
Perfect. Because 3.6 and 3.7 I got down, so those were super easy.
Cool.
I feel like most of this chapter hasn't been too bad.
Yeah. Well, that's good to hear.
And what will this next test be on? Will it be on chapter 3.6, 3.7, chapter 4, and then a little bit of chapter 5?
I'm thinking of including all of chapter 5.
Okay,
Chapter
no
5
problem.
is actually not too bad. We actually start doing trigonometry in there.
Okay. When do we actually start getting like calculus stuff? Is it mostly just algebra basics throughout this class?
And remember, this is pre-calculus.
Yeah.
So I'm just showing you guys stuff that you will need for calculus.
Okay, so you'll be introducing us. So will we be doing stuff like this in calculus?
Yes.
Okay.
It'll make it easier for you guys. So when you guys do move on to calculus, right? The idea behind the notation, how to handle the math, all of that stuff is it becomes a little bit easier to manage once you get to calculus.
Okay. And also, I was also wondering, do you use the calculator a lot more in calculus?
Yes and no. There's a fair amount of sort of arithmetic manipulation in calculus that you would still need.
Okay.
The graphs or a graphing calculator may help you out, but there's a bunch of stuff that you need to be able to do.
I see.
So, for example, I'm going to throw this out here. Why are... Okay, so as an example, what's going on here? Fine, there. Okay, so as an example, do you guys remember when I made you guys do this? No, sorry. I got them flipped. The 3 plus h minus f of 3 all over h.
Let me see.
I think this was actually on either the group quiz
Oh yeah, I remember this.
or the actual exam.
Wasn't it like f(a) plus h minus f, and like you plug in like both things? Actually, what is it? The right end there's the whole entire equation in it, and then yeah, I remember that. Yep, easy.
So that thing turns out there's this thing. So you guys don't know this yet because this So you guys just were able to handle this thing,
Yeah.
right? This stuff over here that's actually calculus.
Oh, damn.
So you guys were actually just able to handle this thing, right? And what this does is essentially free calculus lesson for today. So this whole thing, right? So suppose you have a function f of x, right? What this equation does, it gives you so suppose you want any point. Suppose you want the slope at any point. This whole big, huge equation is the slope of that tangent line, whatever it is. And you guys were I only made you guys sort of figure out how this thing worked, which is the first big part. So you guys see how sort of everything, I mean, this is just one example, but this is the point behind pre-calculus. We show you guys how to handle things like this, right? So that once you guys get to calculus, it's easier to grasp sort of this whole entire thing together.
I see.
Yeah. So technically in this class, we'll see very little, if any, calculus. You guys are supposed to be seeing is stuff to prepare you for it.
That way, when we actually get there, we have all the tools.
Yep.
How much harder do you think the algebra course is before you take this class compared to like, actually, yeah. How hard do you think that this class is compared to the algebra class? Is it, do you think it's like a lot tougher, or is it just like a little bit tougher?
I would say it's a little bit tougher. No, I think this class is, man, it's hard to say. I think my gut would tell me that this class is harder than the basic algebra class.
Okay, yeah.
So the reason why is because of this. I'm chewing. So give me a second. The reason why is because of this. This entire class is supposed to be pre-calculus plus an algebra support, correct?
Yes.
Now, I haven't treated it too much like a pre-calculus with an algebra support. It's been more of like straight out pre-calculus, right? And as we hit algebra problems, I show you how to sort of fix them. Does that make sense?
Yeah.
So I'm not separating the two materials. I'm just sort of teaching you the primary one. And when we get the potholes, we'll fix them as we go. Right?
Yes.
Technically, none of you guys have any prerequisite. You guys have no requirement on any prerequisite for this class. So that means you could have, and many people have done this, you could have signed up for this class knowing basic arithmetic, not even knowing pre-algebra, right?
Yes.
And I am showing you guys how to do pre-calculus. One class before calculus, right?
Yeah.
Normally, you would need to take pre-algebra, algebra 1, and algebra 2. So for us, it was our math 12, math 25, and a math 30. Right?
Yes.
That's a year's and that's 3 semesters worth of math. Right? You guys forego all of that and are just jumping straight into pre-calculus. So you guys are trying to make up for like a year and a half's worth of mathematical knowledge that previously you would have had been required to know.
Yeah, see, because honestly, I haven't taken a math class since junior year of high school, and I'm actually surprised how fast I picked up all this. Like, what was it? I took Algebra 2 as my last math class, and I've actually like self-taught myself a lot of the stuff, like through watching YouTube videos or like Khan Academy has a ton of stuff on their website.
Yep. When in the math lab, that's what people usually tell me, that there's a ton of stuff on Khan Academy that people watch. It's perfectly fine.
Yeah, I just feel like it's so much easier to self-teach yourself math today with all the online resources compared to like 10 years ago.
Yeah. All right. Are there any more questions?
Could you do question 3 real quick?
Number 3. Which one is 3?
The LN one.
Ah. All right. So, domain, how do we do that?
With the 3 minus x.
Uh-huh.
And equal it to 0.
Well, we need that to be greater than 0, right?
Yeah.
So you'd subtract 3 from each side, right?
Okay.
And then the x turn to a 1, so it'd be -3/1.
Right, so there's a 1 there, right?
Mm-hmm.
So an x has to be?
X is greater than 3?
Uh-uh. So what am I doing there?
Putting a negative on the other side.
If I divide by a negative, what needs to happen?
You change the face.
Right. This thing points the other way now.
Okay.
So now we have this thing. What's the domain?
Negative infinity to 3.
Right. Got it?
And the second part is the one I'm stuck on.
Which one?
Finding the intercept.
Isn't the intercept -3/1?
Close.
Is it -3 over +1?
Mm-mm.
Wait, is that what he just said?
Yeah.
Wait, is it 3 over -1?
How about this?
That's my.
So this graph let me see. How about this? Where's the asymptote?
Three.
Mm-hmm. And because of this negative, we know it's doing something like this. Where is this point right here?
Oh, +3?
Uh-uh.
Oh.
Uh-uh. So, vanilla does this, right?
Mm-hmm.
Where's this point? So this point would be what? Right. Now, we flip it. Where's this point now? And because we know that the asymptote is at -3, we know this is the case, right? Where's that point now?
Oh.
Got it?
Okay.
We good?
Kind of.
I know. Okay. I want to move on.
Number 1.
Huh?
You do number 1.
I'd rather not,
Okay.
because I've already done half of them. I'll answer questions afterward. Okay. Was that Sesame Street?
Oh no, I was playing the new Animal Crossing.
Oh, you got it? I want to get it too. I need to buy it, honestly.
I bought it the second it came out, like at 12:01.
A bunch of my friends got it. I need to get it, honestly. I just need to buy it already.
It's so fun.
Animal Crossing's the best.
It is. I've been playing like for hours each day. That's like my
So,
new hobby this
It's just
quarantine.
fun to like build your own town.
It is, and like to catch all the bugs and the fish.
Animal Crossing came out at a good time. During the quarantine.
During the quarantine, yeah. Is that how we're all going to call it, like in the future? Like the quarantine of 2019, or the quarantine of 2020?
Yeah, it's been a weird year to say the least.
Yeah. All right. This is going to be a quick chapter, actually. Well, I keep on saying that, and then I catch myself.
Is it pretty easy?
Yeah.
Great.
It's a bunch of rules. So let me actually bring those up really quick. So I think it was in section 4.1. I gave you guys a bunch of exponent rules, right? So these exponent rules were always true, right? And then you guys got to play around with them a little bit down here, right? There are equivalent ones for logarithms, and they kind of tie into those the exponent ones pretty nicely. So I'm just going to go through them really quick, and then later we'll for your lecture questions you'll be able to use them and see how you can sort of employ them in expressions. The first one, log base 1. That is always going to be equal to 0. And if you take a look, you remember how you can interchange logarithmic forms and exponent forms? That one ties to that one. So b to the 0 is always equal, anything to the 0 is always equal to 1. Doesn't matter what the base is. And that's equivalent to log base b of 1 being equal to 0. The next one, there's a 1 there. And this is going to be automatically equal to 1. And this is the equivalent of saying b to the 1 power is equal to b. No dir, right? The next two are going to be the ones that are most useful when we actually do equations with. Okay? Log base b of b to the x is x. So essentially, what ends up happening is basically both those things cancel out and you get left with just x. And this is equivalent to just b to the x is equal to b to the x, where you have a b to that x, oops, you have a b to this x has to be equal to what's inside the parentheses, right? And then likewise over here, b to the log b cancels, and that leaves you with just x as well. Okay? Okay. Next one is when you have a product of things. When you have a product of things, then you can split them up like so. So all that means is whatever's in the parentheses, you can separate them in addition. This one is closely related to if you have a to the b times a to the c, that is equal to a b plus c. So you have the exponents with the same base, you can just add the exponents. For the subtraction one, this will turn into log base b of m minus log base b of n. You just subtract, so the subtraction of logarithms, or sorry, bleh, the dividing of, bleh, if you want to take two things, divide them, then take the logarithm, it's equivalent to subtracting them separately under the logarithm. Got it?
Got it.
Okay, so using some of the rules. There are two multiplications here, right? I'm going to, and you can do this or you can do them all separately. Doesn't really matter. I'm going to treat them as two different things there, right? So then I'll have log base 3 of 30x plus log base 3 of 3x plus 4, right? And there's a multiplication here, so I'm going to do it again just for these two things, right? So and I have now log base 3 of 30 plus log base 3 of x plus log base 3 of 3x plus 4. I am done. You guys see how that worked out?
So there's no way you could expand the 3x plus 4.
We got a rule for it?
No.
Is there a rule to separate this out?
So why'd you get that log 3x parentheses x? Oh, is it because it's from the 30, huh?
Yep. So
So you wouldn't separate like the 3x since you separated the 30x?
this one right here.
Is it 3x plus 4 greater than 0?
So I'm just asking to expand it. Well, you're thinking you're thinking about a domain and range.
Yes, I am.
Yeah. So we're not doing that one anymore. So this thing over here, there is no rule for how to separate this. And in fact, you can't. You can leave it that way. Got it? Cool beans?
Cool beans.
This one's a little easier. This one's just one multiplication, right? So what does this one reduce to?
Would it be log 8 plus log 8k?
Right, log base 8 of 8 plus log base 8 of k. What is this equal to?
1.
1.
Well, I didn't think I'd get that right.
How is that equal to 1?
I divert your attention up here. It's this one. Got it? Okay. This might seem like a little bit of torture, but I want to give you guys some time to practice with these. So, what I want to do again is I'm going to break you guys up into your little groups. I'm going to give you guys maybe 10 minutes to try out the first one. Is that cool?
Mm-hmm.
Awesome. Okay. I'm going to break you out in your rooms now, and you're off. You guys done?
I'm the only one in here once again, but oh wait. Oh no, I'm not.
Mohammed's in there. I think you guys have. Yeah, Libby can't join.
Connect.
Yeah, she can't connect her mic.
I think I'm done. So I got log base 2 of 15, then plus log base 2 of x minus 1. Then I put the divided by, which is like the fraction, then did log base 2 of 3x plus 4.
Okay, is that positive or negative? At the very
Positive.
end. Yeah, try it again. You're real close though.
Oh wait, is it negative because it's dividing?
It's dividing, exactly.
Oh, so then it would just be the negative instead of the plus symbol.
Positive. Right.
Oh, that's easy.
Let's see how everybody else is doing. You guys
Hopefully
are doing
bad. Just kidding.
Hopefully bad, just kidding. Okay, let's see. I'm gonna join them.
Log 2, 3x plus 4. What'd you get?
Oh, did you just simplify the 15 and 3?
Yes, exactly.
Because I got log base 2. So I did like from the beginning, I did log base 2, 15, and then, the x minus 1, and then minus log 2, and then 3x plus 4.
Yeah, I think it's log. I think you're supposed to do it 3 and then like the 3 and the 5 because it's 15. What we'll do though, we'll ask you just for verification. That way I don't give you the wrong information.
Yeah, for sure, bro.
But
But
since you're in here actually, do you have do you have a Steam account?
Steam, yeah.
Let me add you right now.
Alright, for sure.
Adding Steam accounts, huh?
Steam accounts. Yes, sir. What's your Steam account?
It's hold on, let me see. See, I gotta go on my computer for that one.
How we doing?
Good.
We got both of them.
Boom. Okay.
For the first one, I think, we got log base 2 in parentheses 15x minus 15 in parentheses minus log 2 in parentheses 3x plus 4.
Okay.
Is that right?
Is that not right?
That is correct. But so I think what you guys did was so you guys grabbed that the 15
Yeah.
and distributed it in, right?
Yeah.
Try to keep it separate.
You want us to keep it separate?
Yeah.
Okay.
So what you guys did was technically not incorrect, but you didn't completely expand it out.
So would it be log 2 15 minus log 2 x minus 1?
Not minus.
Plus 1.
Plus 1.
Wait, why would it be plus 1?
Not plus, not x plus 1. It'd be plus log base 2 x minus 1.
Oh, okay.
Got it?
So let me repeat this so I don't forget it. Log 2 15 plus log 2 x minus 1?
Right. And then minus
log 2 3x plus 4.
Exactly.
Okay.
Boom.
So we combined we did the same thing, so just change that for the second.
Right.
Okay. Cool.
Okay. I'm gonna go check another room.
Awesome.
Awesome possum.
So
how we doing here?
I was gonna just ask. Okay. The second one is ln e plus ln x plus 1, and then divide by ln x minus 1, right?
Mm-hmm.
Do we have to go forward more?
Well, yeah. So separate them out.
Wait, that's not separated out. Oh.
That's still not separated out?
Wait, say it again.
ln e plus ln x plus 1
Okay.
and then divided by ln x minus 1.
Not divided by.
Oh, we have to subtract though.
Exactly. There's a subtraction there now.
That's right. Forgot
Oh,
about that.
Oh,
okay.
Yeah. Got it?
Yes.
And then there's one more simplification you can do.
For the ln e, would that just be 1?
Yep.
Okay. Okay.
ln. It's so after the first upper one, it's gonna be minus ln x minus 1.
Yep.
Okay.
So it seems like people are trying to tackle both. So let me call people back in. We'll do both of them together.
Oh, were we supposed to do one particular
Yeah.
one?
Well, yeah. I
Oh.
wanted just to do number one, but
Oh.
you guys are doing both of them. Damn. Okay. Yeah. Let me call everybody back so we can do both of them all at once.
Okay.
Okay. See you guys back over there.
See you.
Boom, 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 boom. How'd that feel? Good?
Yeah.
It's just following rules. It's not too bad, right?
we're back.
Mm-hmm.
It's just following rules. It's not bad.
It's not too bad,
Yeah.
but it's something.
It's something. Yeah, I know. Some of you guys were. I ate my peanut butter and jelly. There's a little bit of a peanut that doesn't want to go down.
Huh.
There we go. Okay. All right, you guys ready?
Yeah.
Okay, so the way I'm going to try to do this is I'm going to split it up by top and bottom, right? Because that's automatic. That automatically gives me one thing I can do, right? So if I do this, I'll have log base 2 of 15 x minus 1 minus log base 2 of 3x plus 4.
I did that dummy wrong. I did like log. I did log 2 3 plus log 2 5 plus log 2 x minus 1.
Not yet.
Oh yeah, I did that hella wrong too.
Yeah, just double check it.
So you don't simplify it. You don't do like. I thought on these you would take the 15 and do log 2 3 plus log 2 5. Does that come later?
That comes later.
Okay, so for this, it's just you're basically just taking each one and basically just separating them.
Yep.
Okay, so it's actually way simpler than actually I did it.
Yeah.
Actually
Me
easier.
too. I thought you had to like. I don't even know.
So let's keep going, right? So that automatically took care of the division, right? And now I have a multiplication between there, right? And that has a rule. Log base 2 of 15 plus log base 2 of x minus 1 minus log base 2 of 3x plus 4. And just like before, there's nothing we can do to this, so that gets to stay. Got it?
Yeah.
Oh, I guess I did do it right. I just put them on top of each other. Is
There we
that still
go.
wrong?
No.
Oh, perfect.
And we are done with that one.
These are easy.
Oh, yeah.
I see what I
Following
did
rule.
wrong.
Following rule. So now, the next one. I'm going to do the same thing. There's a top and there's a bottom. So this is going to be ln of e x plus 1 minus ln of x minus 1. And now in that first one, we have another breakup, right? ln of e plus ln of x plus 1 minus ln of x minus 1.
Yep.
This.
Plus, I made it harder on myself than I had to.
Yeah, that's okay.
This right I'm ready for the next part.
Yeah, this right here. What's that equal to?
Was that 1?
That is 1.
Oh, I actually got this right. Nice.
There you go.
I got the other one wrong because I did this, but I did this one completely right. Nice.
There we go. And this is completely simplified.
Bam.
Okay. Move on. This one is one. This rule is one that we're going to use very repeatedly. Okay. This one is the power rule. So all that happens here is that n pops down. So now I'm going to have n times log base b n.
Okay.
Wait, is that times or minus?
Times.
Okay, it looks like a minus.
Times. Okay, some examples. So, right, that's my exponent. That just drops down, so it's going to be 5 times log base 2 of x. And same thing for this one. This is my exponent that drops down, 2 times the ln of x. You guys see how useful that becomes? Like you don't have to solve the thing inside the you don't have to solve the thing inside the ln or the logarithm. You can just bring the exponent outside, and then you just have the good old just standard logarithm, not logarithm of something to the 5th power. Okay. We can use these to expand stuff, right? So same thing as before. There's a top and there's a bottom. So ln of x to the 4th times y minus ln of 7. There's a multiplication here. ln of x to the 4th plus ln of y minus ln of 7. And now we have the new handy dandy rule here. 4 ln of x plus ln of y minus ln 7. Final answer. How's this looking for people?
How come the y isn't negative in the second step?
It is together, so it came from here, right?
Oh, is that a multiplication or a subtraction?
That is a multiplication.
Oh, okay, that's what threw me off. Okay.
Wait, did you guys hear my? Did you hear my question or no?
No, I didn't hear your question. What
I
was
guess my mic was muted. I think my bad. I was asking about the x4. So you just brought it down and made it an x.
Yep.
So 4. So you put the 4 on the outside. Then you made it 4 ln x.
Yep. That's
Okay.
the rule up here.
Okay. Perfect.
The brand spanking new one.
Sweet.
Okay.
And this will be on also. This will be on the YouTube channel, right?
Yep.
Perfect.
So it's still recording as we speak.
So can the video hear us as well as you?
Yes. So these questions you guys are asking, or will also be on the video.
That's pretty cool.
Yeah. So I think I told you guys, right? So when I made the YouTube channel and I was uploading videos, I didn't know how many of you guys were gonna curse on the video, and I've been known to drop the F-bomb during class. So there's a question in the process for uploading a YouTube video that asks, is this video safe for kids? So and every time I've had to say, no, this video is not safe for kids. Well, I'll have parents send me messages through my YouTube and say, hey, this is not safe for kids. You're supposed to be doing math, not cursing. Okay, next one.
Are other kids doing pre-cal?
Yeah,
Dead ass.
there are kids doing pre-cal nowadays.
What?
Yeah,
Couldn't be me.
it couldn't be me either. Have I ever told you guys, in high school, my first semester, technically, I never finished pre-cal.
What?
Yeah, I never finished pre-cal.
What was the reason for that?
So it was the 2 semesters of pre-cal. My first semester, I got a D, so I had to retake it. And the second time around, I took it, and I got a B in it. But I didn't take the whole entire semester.
Just the thing, I wonder if yourself now or yourself back then would have ever saw yourself becoming a math major.
Fuck no.
If
Hell no.
What did you want to do?
if you're now self told yourself back in high school, guess what? You're gonna be a math teacher when you're older, or a math professor.
I would have been indifferent to it, actually.
You've been like, math? What are you talking about? That's the last thing I'm ever gonna do.
Yeah, no, well, I think to myself, I would have been indifferent to myself. I'd have been like, okay, that's cool.
What did you want to do? Like, what did you think you were gonna do?
Originally, I wanted to do computer science and engineering.
Mm.
I ended up not liking it. Like really, really, really not liking it. I was good at it. I was decent at it, but I really didn't like it. Because it meant many hours. So it meant many hours of me coding in the basement at UC Davis of the engineering department, because I didn't have a computer back then. So I had to go to the Department of Engineering and use their computers. I would go to the basement. I know the sun had set, rose, and set again, and I would not leave that basement. And I had to do that multiple times. Till one day I realized, like, I would be like, fuck, I've been down here for like almost 20 hours and I still can't get this thing to work right. I need to go home, first rest, and 2, rethink what I really want to do.
That sounds like literally the worst thing ever.
It is. I mean, some people actually liked it, and they tended to be very secluded. So sometimes when I needed to get help on the problem, like on the program, very little help from my classmates. I'm like, okay, I'll try to figure it out by myself. And I would pass my classes with like a C more often not with a B, but still, it was one of those things I was like, no, you know what? I don't want to do this.
I wouldn't either.
I wouldn't want to be like the person that got stuck in front of a computer for the rest of their life. So I was like, no, I'm done. Never again. All right, next one.
Yeah.
Okay, we can split it, right? So log x squared y cubed minus log z to the fourth. I've got a nice multiplication split here. So log of x squared plus log of y cubed minus log of z to the fourth, right? And now we can use our new rule that brings each one of those exponents up front, right? So 2 log of x plus 3 log of y minus 4 log z. And now I am done.
Oh, yay, that's what I got.
Boom. Got it?
Yeah.
Okay. So these two examples for example 5, they'll need this thing. Let me actually write it. A to the b divided by c. If you have a fractional exponent, that is equivalent to c a to the b. Okay. I just got an email from the department chair. They're still trying to figure out how to put everybody in the math lab. They're still trying. So it may not be open. The math lab may not be open later on today. No matter what, from 1:15 to 2, I have office hours. I'll be in my office hours room. So if you go to your Canvas page, to where it says online office hours, click on that thing. I'll be in there from 1 to 2. Cool? Cool. Okay. For this one, is that video game?
Yeah. Oh
It
my
is
God,
that
is it
video
hella
game.
loud?
So for this one, we're going to change that square root of x. And the way that we're going to do it is log of x. So this, technically there's a 2 and there's a 1 there. So this is going to be log of x to the 1/2. And all we can do now is we have an exponent. (1/2) log x. Make sense?
Yep.
Okay. This becomes what?
Log 2/3
ln of x to what?
to the 2/3.
2/3. And then this is equal to?
2/3 ln of x.
Right. Got it?
Got it.
Yep.
Okay. You guys got this. Can we split that up?
No.
Really?
So it's common. It's common for people to say, oh yeah, this is ln of x squared plus ln of y squared, right? No. Ever. Never, never, never. Every
It's
time
not
you do
even
that.
2 ln x plus y.
Huh?
It's not even 2 ln x plus y.
Nope. There's no rule. So see how this addition is in between here, right?
Mm-hmm.
There's nothing that allows you to split anything with a logarithm if there's an addition between two things inside. Does that make sense? So you can't do this. You cannot do this. This never happens. Never, never, ever, ever. Every time you do this, a little puppy dies, okay?
I'm gonna do it a lot. I'm just kidding.
Just keep that in mind. This can never be split up. So this is the problem here. So you can't split it up. Okay. Let me see what's left. Okay, I'm going to skip example 6 and 7. That's basically what we did up here, but backwards. So going from here to here, I actually want to get to the change of base formulas. The reason why my internet connection is unstable. Okay. So give me a second. Well, my video is off. What section is this for? 5?
Yeah.
Okay. Okay. So let's say you have a, so that B, right? That B becomes sort of like a little bit of a problem because we don't have a log base B button on our calculators, at least not one that we can get to readily, okay? So instead, what we can do is we can split up this logarithm into basic log base 10. And the way that happens is it's going to be log of M divided by log of B. And notice these are now base 10, right? So then I'm not going to write them. I'm going to leave them off like that. Okay, now, what I want to do now is how many of you guys have a TI calculator?
I have one. I have a TI 84 plus CE.
Okay, cool. So what I want to do is, oh, come on. I'm trying to split my screen up so I can show you guys how to use your TI graphing calculators. So let me share my screen. Okay. Okay, do you guys see my entire computer screen now?
Yes.
Yeah.
With the calculator?
Yes.
Okay. So in order to calculate logarithms, right, you can either do this equation right here, which is actually the old school method of doing it, before we had our newfangled TI-84 calculators, or now that we do have our new calculators, we can calculate them using some functions that are already built in. So, for example, example 8, this would also be equal to log base 3 divided by log 3 divided by log of 5, right? So if we do log of 3 divided by log of 5, we get that number.
Well, how'd you get the log? Can you do that one more time?
So you see the 7 button?
Oh yeah, I see the
7?
log right there.
The right next to it, right?
Your penny press, you put 3 in there, and then it'd be divided by log 5.
Yep. Okay.
The 0.68 and then round up 0.683.
Yep, that's fine.
Okay.
So I'm going to put that 0.683, right? Okay. Newer TI calculators have the log base set into them. So if you hit math, you get all these different options. If you go to the very bottom one, it says log base and hit enter. Okay, what happens? It allows you to put in a base other than 10. Oh, I put them in backwards. Haha. Let's try that again.
Whoa, how'd you get there?
Let's see. Okay, so let me. Okay, so if you hit math,
Math.
so you see the green button, you hit math without moving anything. Scroll down until you hit log base. And now you can put in everything that you need. So 5 and 3. And that's exactly the same.
Oh, damn. It's literally the same like format, and you just get the
Right.
same exact. Nice. Okay. Sweet.
Does that make sense?
Probably not.
These are all easy.
No, because they yeah.
Same thing here. This is log base log 10 over log of 2. So if we do that, log 10 divided by log 2 gets you that.
The flight on the way home canceled.
Or the other one is we go to log base 2 of 10. Same number. You guys got it?
Mm-hmm.
Okay.
Yeah.
We are done for today.
Can you do the first example of the lecture question?
I want you to try it first.
All right. I'll try right now.
So technically I'm done. We got maybe 15 minutes worth of class left. So we'll save that for lecture questions. I'm going to stay on here, wait for you guys to ask me questions.
Log 2x over
So for the first one, since there's an exponent in the one that's like expanded, when we condense it, would that mean that it would go outside the log since it's or would it just stay the same?
You talking about the log 3x to the 5th?
Yeah.
So since you're condensing it, you can leave that one as it stands.
Oh, that's what I was thinking.
So condensing means make it all into one log. Expand it means blow it up.
Okay, that's easy.
Cool.
So for the first one, would it be 2 plus x to the 4th power?
Which one?
The first one? For the top part?
2 plus x to the 4th?
Yeah.
Nope.
Next.
Oh wait,
Check your roll.
wait. I messed up.
Would it be 2x to the fourth?
Yep.
Cool.
Oh.
Okay. Let me. So right now, since I got a free second, I'm gonna go ahead and try to put your guys' chapter 4 stuff up.
When is chapter 4 due?
Well, they all have different due dates, so I need to move those around now.
Are any of them due today?
Well, I haven't decided yet, but no, I'm pretty sure no,
Okay, good.
because I completely forgot to move them over.
Okay, cool.
Picked up a trip for tomorrow.
Really?
Yeah, see, I had it all ready. God dang it.
I have a question
Yeah.
about the recording. Can we play back from the canvas or we have to check it on YouTube?
For now, I think you're gonna need to check it back on YouTube.
Okay, so how can we access, like, is there any title or?
The videos?
Yeah.
If you go to, so if you
Your inbox.
Well, so there are two ways. So the link for my YouTube channel is in the email that I sent. I also put it, so if you know where the, actually, let me show you guys. Let me see. Okay, so then let me go to that thing. So everybody sees the front page, right?
Yeah.
Okay. If you scroll down, lecture videos. So I added this link here.
Okay, got it.
So if you click on there, it'll take you to the YouTube page.
That's great. Thank you.
And like I said in the email, I'm putting all 3 of my classes up here. So if you notice, there's the Math 155, that's you guys. There's my 110, which is statistics, and Math 30 as well. So as the week goes on, or as the weeks go on, this is going to get really, really long, right?
Mm-hmm. Yeah.
The best way to do it is if you go up here and click on playlists. I did separate them into 2 playlists. So there's the 110 stats, the Math 30, and the 155. So you would go to the 155, and it'll separate them out to see how all 3 of them show up here.
Okay. Chapter 2, we dealt with lines.
Oh, got it?
Yeah. Yeah, thank you.
Leo, could you walk us through 31?
31.
In the lecture questions.
Ah, yes. Okay, so 31. So first thing I want to deal with. First thing I want to deal with is this one. Right? Specifically, I've got that 6 up front. What can I do with it?
Does that become the exponent, like 2 to the 6?
Right. So this is the thing that I was talking about before. You get to go backwards. So this is now log base 8, right, of 2 to the 6th. Got it?
No.
Plus log base 8 of 64. And then you have another exponent here.
It'd be a log base 8 of 4 to the 3rd power.
Right. Got it?
No.
Cool.
Wait, is that it?
Hold on.
Oh.
Okay. What's 2 to the 6th?
64.
And what's 4 cubed?
64.
Yeah. So
Yeah. Look at me.
log base 8 of 64 plus log base 8 of 64 divided by log base 8 of 64. What happens with these two things?
It becomes 1.
Yeah, so it's one thing divided by exactly the same thing, right? So log, and look at me, 8 of 64 plus 1.
Oh, cool.
Okay. 64 is 8 to what?
8 to the 2nd power.
Right, so now I can do this. Log base 8 of 8 squared plus 1. And what does this reduce to?
Two log base 8?
Not 2 log base 8. Oh, wait. Yes, you're correct. Let's go ahead and do that. 2 log base 8 of 8, right? Plus 1. What does that become?
1.
Yep. So I just made you guys write the most glorified version of 3 you guys have possibly ever seen.
Wow. I'm gonna keep this in my notes.
Yeah.
If the answer is ever 3, I'm gonna write log base 8 2 to the 6 plus.
Leave it on a receipt as tip.
As a tip. That amount of dollars.
That amount of dollars, yep. You get 6 log base 8 of 2 plus that many dollars. Okay. Let me see.
Can you do the ln with the parentheses and the brackets?
Give me a second. Okay, which one?
The one with the parentheses and the brackets, the ln one.
Oh, that one.
Mm-hmm.
Oh, that one's a good one. Okay. So this is the last one I want to do. I want you guys to try the rest of them. Cool?
Mm-hmm.
Okay. You have an exponent outside. So what does that become?
3 ln.
Right. So this makes it 3 ln. I'm not going to write the stuff. Well, actually, I should write the stuff now. Of x minus 2 x 2x plus 5. Got it?
Mm-hmm.
Now what?
3 ln, then you do x minus 2, then 3 ln x, and then minus 3 ln 2x plus 5.
Right, so we have a top-bottom issue again, right? So then this is going to be ln of x minus 2 x minus ln 2x plus 5. And if you guys notice, let me actually, the 3 is supposed to be multiplied by everything in there. Got it?
Mm-hmm.
Okay, and then finally, right?
Mm-hmm.
What does that become?
3 ln x minus 2, then the 3 ln x, and then minus 3 ln 2 minus 3 ln x, and then minus 3 ln 5.
And the tail end. Can you split this up at all?
Nope.
Nope. You get to leave it alone.
Oh.
Remember that?
Yeah. Oh, that makes sense.
And the only thing that you were doing, Bryce, before was you ended up grabbing the 3 and distributing it in, and that's fine. I just kept it outside.
Yeah, that's a little bit kind of like messy what I did.
Yeah, it becomes messy, but that's okay. I mean, what you did was technically, it's still correct.
Oh,
And,
good, as long as it's right.
Yeah, and we are done.
Yay.
Yay.
How do we look at your like the writing that you did?
The writing that I do?
Yeah, on
So let me go back to, come on. Let me close this. There we go. So remember, so this is your guys' homepage, right?
Mhm.
There's now a bunch of stuff here. Some stuff that was here before and some stuff that I added in recently. So you have the course notes. So if you click on this, you'll get this stuff. Give it a little bit to load. Since there's a lot of stuff there now, it might want to load. It may take a little longer to load, but it's all there. Lecture notes or lecture videos. Those are the ones that, so you guys see how I'm recording right now, right? The lecture videos are going to go there. They're going to be uploaded on YouTube like right after this. And then lastly, this thing. So for now, since we can't get the math lab running yet, I'm going to keep holding my office hours during my office hours times and my lab hour time. So if you guys need to ask me questions, you can still click on this and it'll get you into my Zoom meeting so you can talk to me directly. And I'm going to, by and large, no, not that. I'm going to, by and large, still hold on to my schedule for the week, which looks like this. Come on, there it is. So right now we're Monday. So it's all of this stuff, all here, right? So from 1:15 to 2, I have lab hours, and then from 2 to 3, I have office hours. So I'll be on this link for the online office hours, should people need to talk to me.
Okay.
Got it?
Mm-hmm.
Boom. All right.
Wait, so we got to turn in all the lecture questions today, and we just there's just somewhere to take a picture and turn it in.
Yep. So if you go to whatever lecture question you want to turn in, so let me show you what I'm talking about. So if I go to assignments, actually, hold on. Let me do it this way. I'll show you what is going to happen. So if you guys go, let me do. So you guys are going to go to assignments. And these are undated assignments. Why are they undated? Oh, no, that's fine. So you guys are going to find the section that you need. So these are lecture questions, right? So I'm going to go down to, let's say, 4.2, right? Submit assignment. It's going to ask you for it's going to ask you for a bunch of options. The best way to do this is if you have your Canvas app on your phone, so that you can automatically use the camera on it, okay? It's going to ask you on Canvas, it'll ask you for a file upload, right? You choose the option where it'll let you take a picture from your camera.
Okay.
I don't know if, yeah, mine doesn't let me take, even though I'm on my tablet and my tablet has a camera, it's not letting me take a picture. So you take a picture and then you attach the picture and then you just hit submit assignment and then that's it.
That's easy.
That's my hope. That is my hope. How are people doing?
I'm doing good.
Okay. So at this point, I think, yeah, class was over 10 minutes ago. Time flies when you're having fun, right?
Yeah.
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 Yeah. Who knows what I mean
Having a
by
blast.
fun, but yeah. So I'll stay on here and answer questions, whoever needs it. In the meantime, I'm going to upload the stuff for chapter 4 since I completely forgot to do that. I'll move the due dates so they're not like immediate.
I actually have a question on the very last lecture question.
That one.
Yes. So it says to condense. So when I put everything in parentheses and leave the log out,
Right.
and then honestly, I don't know what to do from there.
So you can condense this thing, right? You can condense this left-hand side,
Mm-hmm.
right? So you can get it everything under one single logarithm,
Yeah.
right? And then you can use this thing from our last class. Was it last class? The class before? I think it was our class before this one. Yeah. You can use this handy dandy thing.
Oh. And
and then
for
that gets
x?
rid of the logarithm.
Oh, okay.
Got it?
Yes, got it. Thank you.
Huh?
On that last one, are we solving for x?
Yep.
All right.
Oh.
I can't believe I didn't put these up. All right. That means we were going through 2 weeks worth of stuff and I didn't even set everything up. God dang it. That is annoying.
I didn't say anything earlier because I thought it was all the easy stuff first. So I was like, oh, okay. He's
Yeah,
going
no.
to do it in later.
Yeah, and good thing it threw up a red flag for you guys. It didn't even register for me. But we're all good. We're all good. Let me see.
I got a question for the log square root 3 cubed and negative, or y negative 4.
This is for today's, right?
Yeah, today's.
This one.
Yeah. I got 3 log x minus 4 log x, or y.
So I would tell you first, take care of that square root first.
Mm-hmm.
So the square root, we can do what?
Ooh, I think I got the last one. All right, I'm satisfied for today. I'm out.
Wait, can you help me with the last one?
Okay, where do you need help with? Where are you stuck?
Well, I just wrote down log 12 parentheses 2x plus 6, then x plus 2, then I did the equals 2 because I didn't know what to do with the equals.
Wait a minute. Oh, wait, what? You said log 12?
And then the parentheses 2x plus 6, and then parentheses again, x plus 2 equals 2.
You got 2x plus 6?
Wait, are you on the last one?
Yeah, I'm on the last one, but what did you do with the x plus 2?
I just put it in parentheses and like kind of like left it there. I didn't really do much with that equation because I was kind of confused.
Yeah, so what I did is I did log 12, 2x plus 6 times x plus 2.
That's what I did.
Yeah, and then, and then I put them together so they made a polynomial, and I got 2x squared plus 10x plus 12 inside the parentheses. That's the first step.
Oh, okay. What'd you do with the equals 2?
So I left it there because there's the original logarithm thingy that where you can switch it to exponential form.
Mm-hmm.
So I got 12 squared equals whatever's inside the parentheses, the polynomial I wrote. That equals 2 goes to be the exponent of 12, of base 12.
So you did the exponent of 2 for the 12?
Mm-hmm.
Oh, and then you just put it in the calculator.
Yeah, and I put the polynomial on the other side, and then
Oh, that
and then
makes
then I simplified it until I got one basic polynomial, and then I did the quadratic equation and I got my x's.
So you got two
Oh,
answers, right?
Mm-hmm. I got x equals 6 and x equals negative 11.
Wait, 11. Oh, 11. Okay, I got it.
Sounds legit to me.
All right,
I'm not quite sure if I was doing it right.
I gotta start my next class in like 10 minutes.
Okay.
Oof, that sucks.
I'll
All right,
see you
cool.
guys
Thank
on
you.
Wednesday.
See ya.
Bye.
Bye.
Okay, so it would be log then x squared, and then
For which one? For
for the one I was doing earlier.
this one, right?
Yeah.
So what does the square root do? What can you change the square root into?
Into a what's it called? A root or a square.
Give me a second.
Okay.
Because I am. All right. I'm going to move stuff to. Okay. Yeah, we'll leave it at that. Okay, yeah, what does the square root become?
A square.
Not a square. So remember what happened to this one, right? Let me scroll back up. So see what happened here with the square root, right?
Mm-hmm.
What happened here was now I have x to the 1/2. So this thing, right, became this thing, right? I was able to pull this out. Same thing with this one. So now this is equal to log of what?
Log of x to the 1/3.
So this is going to remain the same.
Oh, okay.
Mine for now, right? But there was an exponent now. So now this is going to become 1/2.
Okay.
Does that make sense? So then the rule there is the square root of x is equivalent to x to the 1/2. So this is the magic trick I use there. So then what happens with the 1/2?
It goes to the left side.
Where? Tell me what to write.
1/2 log x cubed y negative fourth.
Right. And now this becomes easy peasy.
So, and then you just expand it.
Right.
Okay.
So the hard trick was this, right? What the heck to do with that 1/2? Or what to do with the
Okay.
verb. Got it?
Yeah.
Okay.
Actually, can you explain the example on example 5b? So since you already had the 3, you just
Example 5, right?
example 5 the b part.
This one. Okay. So the rule there, right?
Mm.
So in general, right? A to the B over C. So if you have a fractional exponent, right?
Mm-hmm.
That's the cth root of A to the B, right?
Yeah. Oh yeah.
So all I did for this one is I grabbed this equation right here, right? And I went in the opposite direction. I went that way.
Okay. And that you only use this when you have like 3 different stuff there, right?
Yep.
Okay, I got it.
Okay.
All right, thank you.
Okay. I shall see you Wednesday.
See you Wednesday.
Yep.
Bye.
Stay safe, wash your hands.
Thank you. Okay, you too. Bye.
Yep, bye. On. If you're still there, I'm gonna leave you. I'll be in my office hours at around 1:15. Okay. Besides that, take care of yourself, wash your hands, be safe.